Okay, hello everyone, and welcome back to yet another PyCrafters recap session. So, last recap session, we covered some of the basics of coding. We went over the structure of an Arduino sketch. We kind of went over what IDE means, the E environment, right? We went over what void loop, what void setup do, and we spent a lot of time talking about integers, or int, or variables. So today we're going to get into a bit more of the code. So make sure you have your handouts with you. Remember the one that has const int potpin equals a2 at the top, and it's all the Arduino code. I should have given it to you last week. If you don't have it, please contact me some way, either by the Slack chat or the PyCrafters website, Pt.2, or in the comments or something, and I can get you a PDF or something if you don't have that handout. It's kind of important that you have it because that's what we're basing today's lesson on. So we are going to break it down after, I think we're going to break that down today, and we're also going to get into the rest of what I didn't get into last week. So I kind of just split the video from last week and put it into two parts. So we're about to get into the second part. We're going to talk about all kinds of stuff. So make sure you have a pencil or a pen and paper, and keep lots of notes because you're going to want to keep a lot of notes. I'll tell you some good stuff to write down. Once we get there, I'll say if there's one thing you write down, make sure it's this. Make sure you write that down because future coding endeavors, your future coding endeavors are going to rely on you having that information. Okay, so without much further ado, let's go ahead and get started with the part 2, and once you've watched this, you can move on to part 3. Yay! Alright, let's go ahead. So now let's talk about this digital write. So on the last slide, you saw digital write. Well, what does this mean? Digital write will write or send approximately 5 volts to a digital pin. Okay? So what's this weird thing you've been seeing? Maybe you've been seeing something strange. The digital is lowercase, but then the write has an uppercase W. What the heck is that all about? Well, let's talk about that. So if I have the word digital, and then I do a capital W, and then write. There's a word for this, and that's called Camelcase. And let me show you why it's Camelcase. Think of this as a camel's back, and the W is a giant hump, and then we're back along the back again. Now if I had a number or another letter after this, or another word, that also would be capitalized. So at the beginning of every word except the first one is capitalized. Hopefully that makes sense. So that's Camelcase in a nutshell. And that's what we use for all of the commands. And in the Arduino IDE, it's got this nice nifty feature where all of our Arduino specific commands, such as digital write or pin mode or digital read, all those things, they turn orange, which means that you've typed it in correctly, which is a very nice thing. It's part of the great stuff. It's one of the great things about using an Arduino IDE, right? It's because now that we have that coding environment, we can know whether or not our code is written correctly. And if it isn't, it gives us help on fixing it. And you'll see that once you start writing your own code. So this line, digital write LED pin high, will write or send approximately 5 volts to digital pin 8. Alright, so hopefully digital write makes sense now. We're going to talk a bit more, get a little bit more in depth about that. So notice, again, this is talking about Camelcase, right? And all of our commands are going to be written in Camelcase, and they will pop up orange. And a big thing to notice is after the digital write, you had LED pin, comma, space, high. Okay, so if you see that, LED pin, comma, space, high. The high means that it will emit approximately 5 volts. However, if we did low instead, it would not emit 5 volts anymore. Now, it would not be off, but it would pretty much be the equivalent of off. It's still going to emit a small amount of voltage on low, but it's so small that it might as well be no volts because it's not enough to do anything with. It's not going to turn an LED on. It's not going to show up as voltage, okay? It's pretty much off, but it's not completely off. That's why it's low, and 5 volts is, or high is not 5 volts. It's just a high amount of voltage as opposed to low, which means that that's why we call it high. That's why we call it low, because it's not on. It's not 5 volts. Okay, it's not 5 volts, and it's not off. So if there's anything you write down, write that. Okay? Does not equal low. So write that down, and 5 volts does not equal high. Or you could write 5 volts and then draw a line through your equal sign. It means not equal to. Okay, so you get the idea there. Now, what I wouldn't give for an erase button on this thing. I mean, seriously, I gotta keep pressing undo for all this. But it works. It works. Okay, good. And done. Alright, moving on. Okay, so we talked about digital write a little bit, right? Sends 5 volts. We talked about the high and the low, okay? So now we're going to talk about kind of the opposite, not really, it just kind of goes hand in hand with digital write, and that's called digital read. Okay, so first we kind of have to talk about the pins on an Arduino board. So go ahead and look at your Arduino board and see if you can guess how many different types of pins there are. Well, I'm going to give you the answer right now just because we're going to get through this really quickly, and that's 2. Well, pretty much. Basically, all you're going to use in this class are pretty much 2, except for the ground and 5 volts. And those are, you can probably guess by reading this slide up there, it's analog and digital. Analog and digital. Okay, so those are the 2 types of pins that we are going to be dealing with on our Arduino board. So if you write that down, that would be great. 2 different types of pins, and they are analog and digital. Okay, so what's the difference? This can be rather tricky, and I play a fun game in class that helps everyone through this. If you are not at class, you might be a little confused. However, I usually play this game for about a month every week, just so that it gets into everyone's heads. It helps show them the difference between analog and digital, and the difference between inputs and outputs. So, let me just sum it up for you. So, let's start with digital actually. So digital is like Boolean. It's either Boolean or Boolean, whatever you want to say. Boolean is either on or off, as you can see here. Okay, so these signals are going to be, usually Boolean means true or false. It's one of them, not the other. So if it's true, it's not false. If it's false, it's not true. Hopefully that makes sense. So that's Boolean for you. So in this case, because we're talking about an Arduino, what are the 2 types of things we have with digital read, or digital write and digital read? Really, we talked about this on the last slide. For digital, it's either high or low. Okay, those are the 2 options we get. It's either going to be high or it's going to be low. It's not going to be both. It's going to be one or the other. That's what digital is. Okay, so hopefully you get the idea of digital and Boolean, whatever you say. I like to say Boolean. I don't know. There's 2 ways of saying it. It doesn't really matter. So if there's one thing you write down, that would be another great thing to write down. Okay, so now you got like 12 things to write down. I know. I should have said, you make sure you have a piece of paper before you start. You'll be good to go. So that's digital. Next we have analog. And analog can be a little tricky to explain. I like to think of it like this. Imagine we have a dial, right? And this is off all the way, and this is on all the way. But in between, there's always different, oh, you know what? That kind of looks like the Pokemon symbol. I'm sorry, I just can't draw today. Alright, so in between on and off, we have all these tiny, minute details, and they don't look very minute here because I can't draw. But anyways, you get the idea. So there's not, a knob is not all the way on or all the way off. There's lots of all these little tiny degrees in between. Okay, think of like a temperature sensor where it's not 100 degrees or 0 degrees, it's 100 degrees or 99, 98, 97, 96, 95, all the way down. That makes sense. Hopefully that makes sense. So analog deals with very specific signals, inputs, not so much outputs. Not so much outputs. It just really deals with inputs. Okay, so hopefully the difference between analog and digital makes a bit more sense now. Alright, so let's talk about what this digital read thing is. Alright, so digital read is going to read the input value or the signal from a specific pin. Again, remember this idea of a signal because this is written on all of your handouts. So this should give you a bit of a hint. Signal is going to go to whichever pin we're talking about. Okay, so digital read is going to read that signal. So we have, this is a little bit confusing and I'm not going to spend a lot of time on this tonight, but let's just get through this really quickly. So here we are taking a, okay, I'm sorry, that doesn't look very good. There we go. We are taking a variable that we created earlier called button state, and we are assigning we're assigning value to it. In this case, we are reading the digital value of button pin. Now, since this is digital read, this is either going to be equal to true or false, which means it's going to be equal to high or low. Okay, so now that we've read that value and we've assigned it to button state, we are going to check and see if button state is equal to high. Pretty much if it's on, right? If there's power, which means the button is pressed down. So if button state is equal to high, digital write LED pin high, so turn on our LED. Else, if it's not, because you have to be extremely specific with this computer, if button state is not equal to high, if it's equal to low, digital write LED pin low, essentially turn off the LED. Alright, so we went through that really quickly, and I'm sorry. We might spend the next application night just breaking down what this whole thing means, but for now, just kind of be satisfied with what I just said. I pretty much summed it up for you. I didn't get into really all the specifics, but I think you can get a decent idea for what this means. Alright, so that's digital read in a nutshell. Moving on to analog. Okay, so analog actually uses the exact same commands as digital, except they don't really have a write. There's no analog write, pretty much. So you're never going to see analog write, at least with the code that we are doing. You're really only going to see analog read. So keep that in mind. Analog write is kind of a different thing, and I don't really think it exists. We really primarily use the PWM pins on the Arduino, so if you want to look for those, that would be great. We're not going to talk about them in this lesson, but we use those to control our servos and all that kind of stuff. Alright, so let's take a look at our example from earlier, and it should make a lot more sense. So I've actually broken this down into 3 groups. This group, and then this group, and then this group. If you want to number them, that would help. So I'll do that now, and you can follow along if you'd like. You don't have to do this, but it kind of helps. Here's number 1, here's number 2, and here's number 3. Okay? So that's the order they're in. So pretty much you get the idea that this whole INT section, where we're creating our integers, our variables, goes above our void setup section. That's the idea you want to get here. Okay? So hopefully most of this stuff actually makes sense. We are creating 3 variables, pot pin, LED pin, and val. And then really this void setup section is missing one thing. See if you can guess what that thing is based on this line. I know, it's tricky, but that's actually one of the questions I ask in class. I'm not going to give you the answer to it in this video, but think about it, because that's actually going to help you understand this code a bit more. I'm actually missing something here. Alright, So see if you can think about that. Maybe pause the video or write it down or whatever. Or just circle it in your handout and put a question mark next to it and ask me later in class, hey Bruce, what am I missing in void setup? You said in the video I was missing something. I'll walk you through what you're missing. And then we have our void loop, which is actually between this one and that one there. I'm getting the hang of this writing thing, I think. Alright, and so right, that there, I just said I was getting the hang of it and I messed it up. There we go, so much better. Okay, so in void loop, remember this is constantly a loop. So we have Jerry going through all of our code and reading it over and over again. So this is happening like, I don't know, 30 times a second. I'm just going to throw that number out there. Yes. Go in the comments, call me wrong. I'm definitely wrong on that, but it's a lot. It happens a lot. I don't have the specs memorized, but the Arduino reads this code a lot of times a second, okay? So we have our val, which is actually what we created up here. So up till this point, val has been equal to 0. But now we are giving val some new data. Analog read pot pin. And pot pin is, let me clear this up. Pot pin is pin 2. So when we say pot pin, we're actually saying pin 2. And again, this should be A2, not pin 2. So that's a typo on my part. I apologize profusely for that. All right. So we are reading the analog value from pin A2, and again, that's from a potentiometer, which is a variable resistor, which is a knob. So this value is going not to be high or low, although it might be high if it's all the way up, but you want to think about that knob that we talked about, right? So you're going to have all these different values, again, Pokemon symbol, yay, between here, all these tiny minute values, and this val could be equal to any of them. So hopefully now it makes more sense why we didn't make val a const int, why we just made it a regular int. Because if we had made it a const int, we wouldn't have been able to change this. And we kind of have to change val throughout our code in order to make this work. Alright, so let me get rid of these annoying lines and create a new one. Okay, alright, so hopefully val kind of makes sense. If it doesn't, and I honestly get that it doesn't because I went through that extremely quickly, let me know, Slack chat, whatnot. I'll try to answer all your questions. Alright, don't be afraid to go to the Slack chat and ask me for help. Okay, then we have digital write, LED pin high, which means what? We are turning pin 8 on, and then we are waiting for val. Here's where we use that. So here's our analog read. And again, let's just say this is equal to like, I don't know, 0.5 volts or something. Alright, so let me say val is equal to, that's kind of a D. I don't know. I can't write, whatever. Val is equal to 0.5, whatever. Let's just say that. So then we are delaying for 0.5 seconds. Now again, we're going to get to the delay command in a minute. And then we are digital writing LED pin, which is pin 8 low, which means pretty much we're turning off an LED because there's not enough voltage going through. It is low, not off. Please remember that. And then we are delaying again for val. Alright, so let's move on before you guys like blow your tops and just completely go mental trying to understand this. We're going to cover most of this stuff again in the application night, so don't feel like you're out of the loop or missing something, because I get that you're confused right now. That's okay. I just wanted to show you this to kind of show you where the code would go. You don't have to understand this whole thing right now. Alright, so let's break down what this code is supposed to do. So the result of this code is a potentiometer connected to an LED. When the variable resistor, again, variable resistor is just another name for potentiometer, they're the exact same thing. When that variable resistor is turned, the speed of the LEDs blink will either increase or decrease, depending on where that's turned. Okay, so it's going to blink faster or it's going to blink slower. And a big thing to notice here, big thing, big thing. I really want to get your attention. Big thing. Big thing. Bah, 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 bah. Okay. If there's one thing you get out of this, it's at the end of each line there's a semicolon. That is gigantically huge. Alright. Alright. Good work. You made it all the way to the end of that video. It was pretty short, actually, about 20 minutes, which is good. Back to our normal time now. And we covered actually quite a lot of stuff. So this was part 2 of the last video. So like I said at the beginning, last video we covered a lot of preliminary setup stuff. We covered variables, which was good. Get that stuff all figured out. Today we covered digital write. We did a little bit of digital read, talked about that if then else statement just a little bit. We're not going to worry about that too much in this video. That's the next video. And we talked about analog read. Talked about analog write a little bit, you know, why we don't see that too much. You're going to know why, what we use instead of that. We actually use the PWM pins on the Arduino. We actually use those with a different command for like an analog write type of idea. Like a servo, because a servo isn't all the way on or all the way off. It's got all these tiny little turns, right? You can turn it just tiny, 6 degrees, 2 degrees, 3 degrees. Okay, and all that's done, that would be an idea of an analog device, because it's not Boolean, it's not on or off. It's got turns, tiny little degrees. So since we really don't use analog write, there's the PWM pins for that. So hopefully that makes sense. You'll understand why I was talking about all the PWM pins, and we'll get into that in a future date. So hopefully I didn't leave you guys with more questions than answers. I really hope I answered a lot of stuff. As usual, if you have questions, go to the Slack chat and all the stuff I mentioned at the beginning of the video. Alright, let's go ahead and move forward. You can now move on to part 3.